Hi guys, welcome back. So today we are going to continue our mini unit on simplifying radicals. In the earlier video, because you know we are in round 2 now. In the earlier video we were simplifying radicals by using the product rule for radicals. Today we are going to focus our energy on simplifying radicals by using a quotient rule for radicals. And with your permission, we're going to go ahead quickly review how we can tell if the radical is simplified. Okay, so I'm gonna my equivalent of cut and paste. Okay, so a radical is simplified when we have 4 things to watch out for. If you have a exponent inside the radicand, make sure it's under the index. Okay, if it's the same or higher, then simplify it. Okay, now if it appears that you cannot simplify the radical, make sure that the exponent inside the radicand and the index don't have any factors in common other than 1. If they do, then handle it. Okay, meaning put it in exponential form, clean it up, and then backtrack it to radical form. Now 3 and 4 is pretty much like the same thing, but broken down. Okay, so number 3, if you have a fraction, make sure you don't have a radical in the bottom. And then number 4, if make sure that the radicand doesn't have a fraction. So why not? Because when you use the quotient rule to split the top for the bottom, it yields a hidden radical in the bottom. Okay, so today we're going to do 4 problems and then we're out. I know, I wish we had time for more. So the directions read: simplify each expression, assume all variables represent positive real numbers, write answer in radical form if necessary. Okay, so again, I'm going to go ahead and highlight my favorite disclaimer: assume all variables represent positive real numbers. And I love reading that because if we have an even index, we don't have to throw in the absolute value to ensure that the radicand is positive. Okay, I said too much. All right, so let's do this. So we have cube root of 36 over 125. For the life of me, I cannot enter that off the top of my head. So what am I going to do? We're going to go ahead and use the quotient rule for radicals to split the top from the bottom. Okay, so we're going to write this as cube root of the numerator divided by cube root of the denominator. So let's do this. Cube root of the numerator over cube root of the denominator. Okay, so now you just simplify the top, simplify the bottom, and then make sure that your fraction is reduced. It doesn't matter what you decide to simplify first, just come to it. Cube root of 125. If you know what that is, go for it, but I really don't. Okay, so what I'm gonna do when the numbers don't come to me, I'm gonna write 125 as a product of prime factors. So let me go ahead, bust out a thinking area. So we have 125. When we branch it out, I know 5 is a factor. We punch it into the calculator and it'll give us 5 times 25. Hopefully that's right. Okay, 25, when we keep our cool, that will give us 5 times 5. Okay, so let's go ahead and write 125 as a product of prime factors. I'm kind of at a crossroads in terms of how to write it. Okay, so in this case, I'm going to go ahead just use exponents of repeated factors. Why? Because we got 3 factors of 5 and the index is 3, so I'm working with 3's. So we have cube root of 125, which is the same as 5 times 5 times 5, or 5 cubed. And then what's going on? We have index is 3, power is 3. Since they're the same, they pretty much undo each other or cancel out. And that will leave us with the radicand of 5. Okay, so that is a lot. So let me go ahead and tell the reader what's going on. We're going to take this fraction. Let's go ahead and bring down the numerator, which is cube root of 36. And that's all over our simplified denominator of 5. So fantastic. So that is our answer. There's no more radical in the bottom, which is cool because we don't want to have radicals in the bottom. That was one of our big no-nos. Okay, that's number 3. No radicals in the bottom. Okay, but now what about cube root of 36? Is cube root of 36 simplified? You know what? I really don't know. So I don't know if 36 has a perfect cube factor. I'm not a risk taker, so I'm just gonna write 36 as a product of prime factors, and then I should be able to quickly see if I could simplify it or not. So 36, when we branch it out however you like, I'm gonna go ahead and do 9 times 4, branch out 9, that will give us 3 times 3, branch out 4, that will give us 2 times 2. Okay, so the big question is the cube root of 36 simplified. You know what? I'm going to do that in the thinking area. Okay, cube root of 36. We're going to write 36 as a product of prime factors. And this time around, I'm not going to use exponents for repeated factors. So 36 is the same as 2 times 2. And then multiplied by 3 times 3. Okay, the reason why I typically I was just like a little overachiever earlier, but the reason why I typically don't use exponents for repeated factors is because when I write it out, it's a little bit easier for me to see if I can simplify this or not. Okay, so the index is 3. The only way we can simplify this, the radical further, is if we can make groups of 3 and everyone has to wear the same suit. So we have 2 times 2. We will need another 2 to make a group of 3. So no. What about the 3s? 3 times 3. We will need another 3 to make a group of 3. Okay, so if you have no idea what I'm saying, I'm crying because that means you didn't watch one of the earlier videos. Okay, so in this case, because we were not able to make any groups of 3, then the cube root of 36 is already simplified. So let me put a little love note to myself. Cube root of 36 already simplified. So now the question is my answer really simplified? So the first thing I'm going to point out is this, do we have a radical in the bottom? No. Okay, cool. The radical that exists, is it simplified? Yeah, cool. All right. Now this is a fraction, so I have to ask myself, is it reduced? Yeah, the answer is yes, because there's nothing to cancel the 5 with. Okay, guys, so I think we're good. Well, not for the day, okay, because I said we're doing 4 problems. So that's problem A. Let's go ahead and knock out problem B. So problem B, we have the negative 4th root of the following fraction. So I'm going to put the fraction first because that will be the only way that I will make sure that the actual fraction is the radicand. Let me phrase that a little bit. Don't make the radical sign, typically don't make that radical sign too high. So if I put the fraction first, then I will make sure, I will guarantee that the entire fraction will fit inside the radical sign. Okay, we want the 4th root of that, but we want the negative root. Okay, so in this case, when the radicand is a fraction, what we're going to do, once again, we're going to use the quotient rule for radicals to split the top from the bottom. So that will give us negative 4th root of the numerator divided by 4th root of the denominator. It does not matter which radical you decide to simplify first. For me, I'm just a big fan of simplifying the bottom first because I want to make sure, like, hey, make sure we don't have radicals in the bottom. So let's do this. I'm going to bust out a thinking area. So we have 4th root of y to the 20th. Do what you gotta do. We all process things a little bit different. This is first problem from this round, so I think I'm gonna just speak to myself all the way. For me, when the numbers don't come to me, then I'm gonna go ahead and write this in exponential form, or in English, get it out of the radical. So to do that, we're gonna keep the base and write the exponent as a fraction. So to do that, it's gonna be current exponent divided by the index. We take our time. Quotient of 20 and 4 will give us 5. And we have no remainders. Okay, so the moral of the story is that the 4th root of y to the 20th simplifies to y to the 5th. You know, while we're at it, let's go ahead and simplify the numerator. 4th root of x to the 27th. Okay, so let's go ahead and do this. Put this in exponential form. Okay, so we keep the base and then write the exponent as a fraction, which will be 27 over 4. Now, as you can see, the 27 over 4 is not going to give us a clean integer, so we want old school answers, meaning go ahead, highlight the quotient and remainder. Don't get like all excited and give me a decimal. Okay, so in this case, I don't know the answer. Okay, 4 goes into 27. I think it's 6 times. Okay, 6 times with the I have no idea. Okay, because I'm having a moment. Okay, this is why we need to sleep, people. Okay, how many times does 4 go into 27? Yeah, I had to take it there. 4 goes into 27 almost 6 times with the remainder 3. Cool. All right, so if you need this, then I guess go for it. If you don't need it, then I don't need it, but apparently I did. Okay, So thanks to my thinking area nested inside my other thinking area, we have that 4 goes into 27 at most 6 times with the remainder 3. Okay, we're not gonna get all creative and put like 6.75. No, the decimals is not gonna help you. Now check it out. The quotient will tell you how many factors of x are gonna come out. The remainder will tell you how many factors of x, if any, will stay inside. The quotient is 6, so that will give us 6 factors of x that come outside the radical. The remainder is 3, so that means that we're gonna have 3 factors of x left inside. If you have a leftover radical, please make sure you preserve that index. In this case, it's 4. Okay, so we're gonna go ahead bring that to our solution. Okay, the numerator, thanks to our hard work, 4th root of x to the 27th gives us x to the 6 times 4th root of x cubed. X to the 6 times 4th root of x cubed. Let's not forget to bring down that negative sign. So the negative sign is in front of the radical. I mean, we're going to have a negative fraction. It doesn't matter where you place the negative, top, bottom, or center in the middle about the fraction bar. Just put it anywhere. Okay. The denominator, thanks to our hard work, simplified to y to the 5th. So the question is, are we good? I don't know. We got a fraction. There's radicals involved. So the first thing I want to ask myself is this. Is there a radical in the bottom? There better not be. Cool. The radical that we do have left over, is it simplified? Yeah, we did it on the side. Alright, now for the grand finale. This bad boy is a fraction, so ultimately I need to ask myself, is it reduced? And the answer is yes. Okay, so we checked off all those boxes, so we're good. Cool. That's 2 problems down, 2 more to go, and then we're out. Okay, well, my original game plan was just to do those 2, but I'm an overachiever, so let's do this. So we're going to take the cube root of another fraction. Let's go ahead, put the fraction, the radical, and then the index. So the fraction is 81 times x to the 5th over y to the 6th, and we want to take the cube root or the third root, however you want. So I for one don't know what the answer is, so let's go ahead and use the quotient rule for radicals to split the top from the bottom. So we are going to write this as cube root of the numerator over cube root of the denominator. Cool. Typically don't do thinking areas. When I simplify the radicals, I usually just keep writing down, but thanks to problem B, I think I'm going to do that starting now. Okay, I like this solution. Okay, let me go ahead, bust out a thinking area, and then you simplify first whatever you like. I gave you my piece why I simplified the denominator first, but it doesn't matter. You got to do both anyways. Cube root of y to the 6th. Now, if we were to write this in exponential form, pretty much what this boils down to is how many times does 3 go into 6? 3 goes into 6 exactly 2 times, okay? So that should simplify to y squared. But for those of you that are like, no, I'm an overachiever, or I just want to make sure I did it right, then go ahead, speak to yourself again and write this in exponential form. Okay, so in exponential form, that will give us y raised to the 6 over 3. Cool. And then we take our time. Quotient of 6 and 3 will give us 2 with no remainder. So the moral of this story is that once again, cube root of y to the 6th, that simplifies to y squared. Cool. All right. Now, what about that numerator? We have cube root of 81 x to the 5th. Okay, so there's 2 things that I gotta take the cube root of. So one is 81 and the other one is x to the 5th. Now, if you know what the cube root of 81 is, more power to you, but you're not gonna take the test for me, so I'm gonna show all the work because I don't know the answer. So with your permission or not, we're going to write 81 as a product of prime factors. So let's do this. 81, 9 times 9. 9 is the same as 3 times 3. 9 is the same as 3 times 3. Okay, so you're more than welcome to write 81 as a product. You're more than welcome to use exponents for repeated factors. You know, you can write 3 to the 4th, and then you simplify like we do with the variables. But for me, I love making groups for the integers, so I'm not gonna use an exponent for repeated factors. Okay, so that will give us cube root of 81, which is the same as 1, 2, 3, 4, 3 to the 4th power, 1, 2, 3, 4 times those 5 factors of x. I almost ran out. Okay, so I'm going to focus my energy on taking the cube root of 81 first, and then I'll worry about the x's. Okay, since the index is 3, then we want to make groups of 3, and everyone needs to wear the same suit. Okay, 1, 2, 3. Okay, now you have some options. You can either write give me the simplified product of 27 and then ask yourself what's the cube root of 27, or you can just use exponents for repeated factors. That's how I'm going to take it. Okay, so that will give us cube root of 3 to the 3rd power. So if you are in a group, then you get your own cabana. If you're not in the group, then you go with the other one. Okay, you get tossed in with the separate radical. So we're gonna put that we're gonna write this as 3 cubed times 3 times x to the 5th. Fantastic. So let's go ahead, work our magic, and earn our full credit. Cube root of 3 cubed, check it out. Index is 3, power is 3. Since they're the same, they pretty much undo each other, and that will leave us with the radicand of 3. Fantastic. Then what is going on? We're gonna multiply that by the cube root of 3x to the 5th. We cannot simplify the cube root of 3. We don't have enough factors of 3. So that will stay inside the radical. Cube root of x to the 5th, we could totally do that. Okay, if we were to put this in exponential form, with like write it without the radical, what this boils down to is how many times does 3 go into 5? And I'm just gonna write that on the side. How many times does 3 go into 5? If you don't like this, then go ahead, write it in exponential form like we did for the cube root of y to the 6th and the other problems. Okay, 3 goes into 5 at most once, with the remainder 2. Okay, so the quotient is 1, so that means that one factor of x comes outside. The remainder is 2, so that means that 2 factors of x stay inside. Okay, so let's go ahead, transpose this or bring this to our problem. Okay, the numerator, thanks to our hard work, cube root of 81 times x to the 5th gives us x times 3. But who speaks like that? We're going to write 3 times x multiplied by the cube root of, where am I? 3x squared. And that's all over the denominator. Cube root of y to the 6th, that's simplified to y squared. Okay, let me go ahead, do more thinking. You know what? I regret that. I wanted to highlight to speak to myself, but I think I made that worse. Ignore that. Okay, so now the question is this bad boy simplified? Because the directions just read simplify each expression. Okay, cool. We got a fraction. There's radicals involved. I need to make sure that we don't have a radical in the bottom. Okay, we don't. We do have an existing radical, so we just need to ask ourselves, is it simplified? It sure is, because if not, we would have taken it down. We would have taken care of that earlier. For the grand finale, it's a fraction, so can I reduce it? The answer is no. There's nothing to cancel out. Something that I want to point out is this. You may be tempted to, oh, I know, I lied. No, I thought this was something else. Okay, guys, so that is it. Sorry, it's I'm reading off my screen instead of my paper, so sometimes I don't see things. Okay, so the 4th and final problem. So let's do this. We have 4th root. Oh, I'm putting the radical first. Hopefully the entire fraction fits inside. 4th root of this fraction, 32xy to the 8th over z to the 16th y to the 20th. Okay. For the life of me, I have no idea what this simplifies to. So what we're going to do, we're going to use the quotient rule for radicals to split the top from the bottom. Okay, so we have 4th root of the numerator divided by or over, you know what, I need a separator. Okay, divided by 4th root of the denominator. Okay, so let's go ahead, simplify. I'm gonna bust out a thinking area. So again, I call it thinking area because that's what they do in the comics, you know. It's the area where I think. Yeah, I don't read comics. All right, so we have 4th root of z to the 16th w to the 20th. Okay, so if we were to put this radical in exponential form, what this pretty much boils down to is how many times does the index go into each exponent. Okay, So 4 goes into 16 exactly 4 times. So that will give us z to the 4th. Fourth root of w to the 20th, if we were to put it in exponential form like we did earlier, what that boils down to is how many times does 4 go into 20. Okay, so 4 goes into 20 exactly 5 times, so no remainder. Okay, so thanks to our hard work, we're going to let the reader know that the fourth root of that bad boy simplifies to z to the 4th times w to the 5th. I need a separator in my thinking area. So let's go ahead simplify the numerator. So we have a fourth root of 32 times x times y to the 8th. Fantastic. I'm not quite sure what this simplifies to, so with your permission, I'm going to write 32 as a product of prime factors, okay? So 32, let me branch it out. That's 8 times 4. We branch out 8. I'm going to do 3 branches for the purpose of the length. And 4 is the same as 2 times 2. So we have that 32 is the same as 2 to the 5th power. But you know my style. If not, oh man, I'm crying, okay? I'm not going to use exponents for repeated factors. So we have 32 is the same as 2 times 2 times 2 times 2, 2 to the 5th power. 1, 2, 3, 4, 5, multiplied by the x, multiplied by those y's. Okay, I'm going to go ahead take care of the fourth root of the integer, and then I'll take care of the fourth root of the variable factors. Fantastic. So for the integers, since we are looking at the fourth root, then we want to make groups of 4, and everyone needs to wear that same suit. So we have 1, 2, 3, 4, and this single 2, we're just going to toss it in a separate radical. So if you are in a group, you're going to get your own radical. So let's do this. So that will be fourth root. Now we'll use exponents for repeated factors. So someone said, Miss Torres, how come you don't just write down the simplified product? Why don't you write 16? I'm going to tell you right now, because I'd rather attack the fourth root of 2 to the 4th than the fourth root of 16. And it's a personal choice. We'll get 2 either way. Okay, so now, I told you the answer. Okay, so index is 4, power is 4. They're the same, so they undo each other. And that will leave us with the radicand of 2, which I wrote prematurely because I usually bring down the rest of the work. But when you're nervous, you're nervous. Alright, times the fourth root of whatever we have left, because we have 2 to the 4th, then we got to put times 2 times x times the y's. Times 2 times x times the y's. Okay, so let's go ahead continue to simplify the radical. So we have fourth root of 2, which we cannot simplify, because if we could, then we would have had another group. Fourth root of x. So again, if we were to put this in exponential form, what this boils down to is how many times does the index go into the exponent. So I'm like, how many times does 4 go into the exponent of 1? No times. Okay, we can't clean it up. Okay, so x is going to stay inside. Fourth root of y to the 8th. Again, what that boils down to is how many times does 4 go into 8. 4 goes into 8 exactly 2 times, so that will give us y squared. So I think we're done. Let me just put a erase dot here so it could make it look a little bit less weird. Let's go ahead bring down what we have. So the numerator, thanks to our hard work, let's clean it up. We're going to write 2y squared times the fourth root of 2x. The denominator, thanks to your hard work, where am I? Z to the 4th times w to the 5th. I would hate to do all of this work and then realize like I could still simplify more. So let's do this. We got a fraction, there's radicals involved, so I'm going to ask myself, do I have a radical in the bottom? We do not. The radical that remains, is it simplified? Yeah, because if it wasn't, then we would have kept going. Ultimately, this is a fraction, so I need to know, is it reduced? Yeah, because there's nothing to cancel. So we are on track to earn our full credit. Okay guys, so I said we were going to do 4 problems, so that was it. Hopefully you made it to the end. Alright, thanks.